Okay, so let's finish up symmetry by taking a look at 3D objects. So what are 3D objects? 3D objects are just objects that have length, height, and breadth or depth. Okay, so they have length, height, and breadth or depth. Breadth is um, uh, length is from left to right, height is from bottom to top, breadth is from where your screen is to the inside. Okay, so um, let's see how to do symmetry. So for 3D objects, we normally start what is called plane symmetry. Okay, plane symmetry. So plane symmetry, first, what's a plane? A plane is something like a paper. Okay, it has length, it has height, it doesn't have breadth. So that's a plane. So to know what plane symmetry 3D objects have, when you see a 3D object, you have to ask yourself, how many times can I cut this with a knife such that the two sides that are going to come out are going to be identical. Okay, so we can study shapes by looking at 3 categories of shapes. The first are called, we're going to call them irregular shapes. Okay, okay, shapes like this. Okay, something like this. Okay, so for such a shape, it's not identical. No matter how you can cut it, you can't have two identical parts. Okay, because if you try to cut it here, this side and this side are not going to be identical. If you try to cut it here, this side and this side are not going to be identical. No matter what you do, they cannot be identical. So these ones have 0 planes of symmetry. 0 planes of symmetry. What about rotation symmetry? Rotation symmetry, an object has a rotation symmetry of at least 1. Okay, therefore, if you think of this, there's a way in which you can rotate it. All you need is to think of where to the center to rotate it about. You can think of a center as getting a wire, then you pierce through this object. Okay, so when you pierce through the object, what you're going to get, when you pierce through the object, you ask yourself in your mind, so if I pierce it on this center, if I rotate it, how many times is it going to have positions where it looks exactly the same as it was at first or as it is now? Okay, in this case, you can rotate it. The only time it will look the same is when you come back here. So it's one, it is a rotation symmetry of order 1. It is a rotation symmetry of order 1. Okay, so that's all about irregular shapes. They don't have planes of symmetry, and they have a rotation symmetry of order 1. Okay, the second types of shapes are called pyramids. Okay, so what's the deal with pyramids? Okay, so we're going to start pyramids with regular bases. Okay, so a pyramid looks like this. We can have this situation. Okay, so this bottom part is called a base. Okay, this bottom part is called a base. Okay, so the base of the pyramid determines how many planes of symmetry the pyramid has. It also determines the order of rotation symmetry of this pyramid. Okay, so if the base is regular, to be regular, it means all the 4 sides are the same. So if all the 4 sides are the same, then the number of planes of symmetry is just the number of sides the base has. In this case, it has 4 sides, hence the pyramid has 4 planes of symmetry. Okay, what about rotation symmetry? Okay, rotation symmetry, again, if you think of piercing a wire through here like this, okay, like coming out from there. Okay, so you can rotate this 4 times. Okay, so if the base is a regular polygon, or it has all sides the same, then the number of sides is equal to the planes of symmetry and is equal to the order of rotation symmetry. Okay, another example could be something like this. Okay, okay, so this has a triangular base. Again, the number of sides 3, hence planes of symmetry 3, rotation symmetry 3. Okay, so that's everything about pyramids. Next, we look at a prism. So a prism is a shape that has two opposite faces which are identical. So it can be something like this. Okay, let me make it simple. We'll start with this one since it's a prism. So all these three are prisms. All these three are prisms. Okay, why? Because this face is the same as this face here. Okay, so two opposite faces which are identical. This one, the top face and the bottom face are the same. This one, the left face and the right face are the same. So these are prisms. Okay, so and other than just having identical faces, prisms should have the faces connected by rectangles. Okay, of course not all the time, but most of the times. Okay, there's one prism that tends to break this, but in this case we can see a triangle here, I mean a rectangle here. Okay, this is a rectangle. Okay, so even here we have this rectangle, even here we have this rectangle there. Okay, so how do we get planes of symmetry for pyramids? I mean for prisms. Okay, so there are basically 4 types of prisms. 3, you can master them. Just from the name, you can know that this one has this number of planes of symmetry. 1, you need to do some thinking a bit. So the first is a cube. Okay, so a cube is like this one, but they differ a bit. So a cube is like this. I'm trying to draw straight lines. Okay. So this is a cube. Okay, even behind there is a face. Okay. So all the sides of a cube are the same. So how many times can you cut it? You can cut it like this. Okay. That's 1. You can also cut it like this. That's 2. You can cut it like this. That's 3. You can cut it like this. That's 4. You can also cut it here. That will be 5. Okay, you can cut it like here. 6, you can cut it like here. 7, you can cut it like here. 8, you can cut it like here. 9. So a cube has 9 planes of symmetry. 9 planes of symmetry. Okay, the other one is a cuboid. Okay, a cuboid is this. So a cuboid, again, for a cuboid, the way to analyze this is the same as the way to analyze this. Okay, other than a cube, there is a cuboid. So but the cuboid, we're going to analyze it together with this. Okay, we look at the other type called a cylinder. Okay, I wanted us to start with a cuboid, but change of plans, let's look at the cylinder. So a cylinder has a circle on top, then like this, Let me use black. So on top it has a circle. It's doing fireworks. All right, so it's like this. Okay, so for a cylinder, since it has a circle, the number of planes of symmetry is infinity. You can cut it so many times. Okay, so many times. So it's infinity. That's the number of planes of symmetry. Even rotation symmetry, also it is uncountable. Okay, or endless. Okay, so that's the thing with cylinder. Okay, now we go to the last one, this, and this. Okay, the analysis is the same. So for such shapes, okay, the number of planes of symmetry depends on the face again, just like a pyramid. Okay, you look at the face, the number of sides, but unlike in the pyramids were just getting the number of sides. Okay, but here you get the number of sides, then you add 1. Okay, why? Because the number of sides tells us the number of planes of symmetry. You can cut this like the 1, you can cut it like this, 2, you can cut it like this, 3, you can cut it here, 4, you can cut it there, 5, you can cut it here, 6, right? But you can also cut it here like this. Okay, even behind there. So when you cut, then the upper part and the bottom part are going to be the same. So the easiest way to do is to count the number of corners, then you add 1 if a shape is like this 3, that is having equal opposite faces, okay, and connected by rectangles. Okay, so this has 7 planes of symmetry. What about rotation symmetry? Rotation symmetry depends on the center you have chosen. So most of the times we can choose this as the center, the middle part as the center. So the number of rotation symmetry is equal to the number of sides. Okay, the number or the order of rotation symmetry is just the is equal to the number of sides of the face. Okay, so we know that there are 6 sides, hence rotation symmetry is of order 6. Okay, but planes of symmetry are 7. Same situation here. Okay, how many corners? We have 4 corners. Okay, so so we have 4 corners. So these 4 corners plus 1 becomes 5 planes of symmetry. Okay, what about rotation? It will be 4. Okay, what about this? There are 3, so it's 3 planes of symmetry. What about rotation? Rotation, it's going to be, sorry, I was disturbed a bit. So there are 3 sides, so the total number of planes of symmetry is 3 plus 1, 4, right? Then total number of rotation symmetry is 3.